Optimization question, surface area, and we're going to be using a cylinder. It says a soft drinks company wants to design cans to hold 300 milliliters of soft drinks. Find the dimensions that will minimize the amount of material to be used to construct the cans. So when we do these types of questions for optimization, we're going to follow some steps. And the first one is going to be to draw a diagram. So we have a cylinder. So if we draw a cylinder, so what do we know about a cylinder? Well, we have a radius and we have the area, the top and the bottom. So if I was to open this out to draw a net, we're going to have a rectangle plus two circles. So we need to use this material, surface area, to construct our can. So what do we know? Well, the area, so the area of our circle, so this is going to be pi r squared. And then we know that the circumference of a circle, so this is it, let's write area. So the circumference of the circle is the distance around, so that's going to be this distance here. And then that is going to actually be equal to this length here too. So the circumference is 2 pi r. Now I could use pi d, but because I'm using the radius, I'm going to use 2 pi r. So the area for this is going to be the length of 2 pi r multiplied by the height. So this is the height of our cylinder. So the area of our shape, so let's write that here. So the area of our cylinder, let's write surface area of a cylinder. So we'll have the circle at the top and the bottom, so that's 2. So that's going to be 2 pi r squared. Plus, then we've got the area of the rectangle, which is going to be 2 pi r h. So what else do we know about our circle? Well, we've got in the question 300 mil. So 300 mil is going to be a volume. So the volume formula is going to be for a volume. This is going to be the area, which we said is pi r squared multiplied by the height. And the volume is equal to 300 mil. So the next thing we need to write down is the conversion. So we're going to write down the volume in terms of the height. So let's rearrange. So the volume is pi r squared h, and we know it's 300 mil. So I want to rearrange my equation. So if I divide both sides by pi r squared, so this will simplify. So h, which I'm going to just write here, is 300 divided by pi r squared. So we're going to use this information and we're going to substitute into the surface, substitute into the surface area equation. So let's just do that. So we have, instead of h, I'm going to be writing this in my equation. So the surface area is 2 pi r squared plus 2 pi r multiplied, and instead of h, 300 divided by pi r squared. So now I need to look at simplifying. What can I do? So I'm going to factor by 2 pi. Now, if I factor by 2 pi, this will leave me with r squared plus r multiplied by 300 divided by pi r squared. Now I have an r here and an r here that will simplify. So I'm going to cancel one of those. So let's rewrite. So we have the surface area is 2 pi r squared plus 300 over pi r. Now, if I want to add two terms together, I need the denominator to be the same. So I need my r2 to be divided by pi r. So I'm going to just rearrange. And because I need to find the derivative, I'm just going to rewrite our denominator. So let's write this a second as 2 pi r squared plus 300 pi r to the negative 1. Now by doing this, it's going to make this easier. So we need to find the derivative of this term. So find the derivative. So by taking the derivative of the surface area, and this is in respect to r, because we're using the radius. So this is just going to be, so I've got 2 pi outside. Now I'm going to take the derivative, so this is going to be 2r. And then our negative 1, so this will be negative 300. And this is going to be pi r to the negative 2. So just rewriting this now. So I have 2 pi, and then I'm going to rewrite this. So our pi r squared on our denominator. So like I said, I need to have these terms the same before I can add or subtract them. So I'm going to multiply through finding the derivative. So we've found the derivative for the area, but we now need to simplify. So what we're going to do is multiply through by pi r squared divided by pi r squared, which is just 1. So when we actually do this, the first term is not going to be changed, but we're going to multiply this term here, which is 2 pi over 1 by pi r squared. So we'll have the surface area is 2 pi, so 2 pi r cubed divided by pi r squared minus 300 over pi r squared. And we can now rearrange this. We can set it equal to 0 to find the critical numbers. So let's write this. Find the critical numbers. So we need to set it equal to 0. So 2 pi r cubed minus 300 equals 0. 2 pi r cubed is equal to 300. Dividing both sides by 2 pi. So we'll have pi cubed is 300 divided by 2 pi. So to find the radius, we're going to take the cubed root of 2 pi, which is going to be approximately, if we round it to the nearest tenth, 3.6. So this is rounded to the nearest tenth. Now, because we found the radius, we can substitute this into the equation for to find the height. So the height we said was the volume, which was 300, divided by pi r squared. So we're going to substitute in the radius is 3.6 squared. So the height is going to be rounded to the nearest tenth, 7.4. So to optimize, so to find the minimum material used, so this is for the minimum material, we're saying the radius is 3.6 and the height is going to be 7.4. So let's just check this. We can use Desmos to do that. Okay, so I put the equation into Desmos, and just in case you didn't know how to do that, so we can actually put in, so A and is equal to, so what I've done for pi is 2, and then we just press pi and it will convert it to pi. So we had the brackets, I'm using R, so I'm using my keyboard and changing it to R. So we've got plus 300, and this is divided by pi, so pi multiplied by, and then we've got R, so R on my keyboard, there's R. And then back to my brackets. Okay, so looking at our graph here, we can see that when the radius is 3.62 or 3.6, as we said, our surface area is going to be 248. So using our original equation, if we substitute in 2 pi 3.6 squared plus 2 pi 3.6 multiplied by 7.4, our surface area will be 248.81.